Hello, and welcome to the Science Project Series. Today we're going to talk about how to create a project plan, and that is a three-part series. The first two are pre-recorded videos, this one that you're listening to, and another one that will talk about research at the library. And then on the 23rd, we will meet again for the final part of this, of how to create a project plan. So let's get started. Just a quick note, the Let's Get Started video, there are two versions. One is for the engineering design project and one is for the science inquiry project. And let's make sure that you're on the right one. We'll talk about the types of projects. So an inquiry-based project is a science fair project that you're probably relatively familiar with. It incorporates a scientific method such as the question, the background research, hypothesis with variables, an experiment to test, and procedure to test your hypothesis with your analysis and conclusions. The engineering design project is a process that is an innovation or an invention or an improvement on a current design. So if you are doing an engineering design project, then you are watching the right video. If not, close it and go watch the science inquiry one. But the processes are relatively similar. They have steps in it that are similar. The research is exactly the same in both of them. The steps otherwise, the scientific method and the inquiry and the engineering design process for engineering projects. So what is the engineering design process? Well, the first step is to define a need, and then to do background research, establish design criteria, prepare preliminary designs, build and test a prototype, and test and redesign as necessary. So the first three we'll talk about today in this video. The second three we'll talk about when we get together on September 23rd. So define a need. What is a need? Well, a need is a problem to be solved. Engineering design is really based on consumerism as an application of science. So we use technology to solve a problem. And so the problem that needs to be solved is the need. Define a need that is currently not being met with perhaps a new design. Or you can define a need in a product that can be improved of a current design. So for example, some aspect of the current design that has an unintended result that's not appealing to a customer or a consumer. Maybe it's too heavy, it's hard to use, hard to move, or it has a design flaw or a bug in it. Or the current design can be improved since the technology and materials have been improved since its original release. So to define a need is defined by a customer. So you say, well, why does a customer make a difference? Well, we go back to the bicycle example. So if I say, I need you to design a bicycle and I want you to start to draw it. And so you would start drawing tires in a car, in a seat where you're going to sit on the bike, and the handlebars, some of them might be pointed down as in a speed bike and some of them might not be. But then what if I said, but I need a bike for a 2-year-old? Well, that changes your design quite a bit, doesn't it? You have to have probably 3 wheels now. It has to be lower to the ground. It has to be more indestructible, right? Some plastics and stuff, fewer complex parts. So the customer or the consumer of your product or the solution that you solved of the need needs to be defined. So one thing that you might notice, though, is that consumers may express their needs by describing a project. They'll say, I need a car. But that's not the problem that's being solved. The problem that's being solved is that they need a way to get to school. So make sure that you're in the solution world instead of the problem-based world instead of the solution world when you're creating your need or the need statement. The need statement should be described as a simple statement that includes what you are designing, the product, who's it's for, the customer, what does it satisfy the problem to solve, and how does it improve previous designs, easier to use, less expensive, or more efficient, safer, etc. Examples of the need might be design a hearing aid that will improve the hearing capacity of hearing impaired people by lowering the frequency of sound in real time. That would be kind of an interesting project. Software. Or design a software program, so you can tell I'm a software person, for STEM project fair participants to evaluate the performance of an engineering design or determine if the hypothesis has been validated. So this would be, you know, some kind of a tool that manipulates your data so that you can see that if something's been met. So what you need to research. So you'll research the desired functionality so that you understand the need. Determine the limiting factors and criteria for success for meeting the design, you know, such as cost, or a limiting factor might be weight. If you're using some type of material and you're like, ooh, that would be too heavy, so I need to change that, right? Research materials and processes to be used in your proposed solution. So research current and similar designs, evaluate the designs. So each design that you look at will have strengths and weaknesses, and then compare them. And then when you put together your solution, you can combine some of the components of the designs that you looked at. Like, you know, these parts of these designs were good, and these parts of those designs were good too. And so you could combine those into your solution. And change some of the components of the research design and maybe add an original component. Generate 2 or 3 separate design ideas in your evaluation phase, and after research, you should be able to write a design statement. So also keep in mind that you have to determine the test criteria to evaluate it, right? So in an engineering or in a scientific inquiry project, you have a hypothesis and your experiment is used to test your hypothesis, and therefore you validate or invalidate your experiment or your hypothesis. In an engineering design project, your tests are used to validate if you've met your criteria. So your design criteria, the functionality that you say you're going to do, or you have to be able to validate that. Say you have to have a way of proving that you've met your design. So determine the test criteria to evaluate the solution, so you know whether you've met it or if you need to change something up, and apply to the generated ideas to evaluate which approach is best to continue onto the project. And if you're doing a change, right, improvement on a current design, you will need to have a baseline. So you can say you should show improvement in the speed, or whatever you're doing to improve the functionality of a current design. You need to create a baseline test of what it does now, so that you can compare it to show that you have improved it in your new design. You might also talk about other things like develop test cases, such as safety mode, if there's a safety mode of something that you're doing, or a manual mode, or a normal user mode. So you might have to have different types of test cases or different tests that run depending upon whether you're in safety mode or normal user mode. Right? So now you can create your design statement. A design statement expands the need into an intended solution. So, for example, the format or the product shall provide the user with the functionality requirements. This is what it should do, using some materials or tools that you'll use. So a product can be hardware, software, or a combination. A user must be defined. Materials are components of the solution, what you're using in the solution, and tools or apparatus for building and or testing the product. So you would need all those in your design. You would also establish evaluation criteria for the project process or success, and establish mitigations or alternative design plans for any limiting factors that come up. So say you have to, in order to get something to work, you have to add a certain component, and all of a sudden now you've passed some weight limit that makes it impossible to use or something. So you'll have to establish mitigations for possible alternate design needs. So you have a design statement example. So for example, the water filter or the product shall provide victims of the flood, which is the user, with a way to clean and filter water for drinking. So you'll put the functionality requirements, and then of course underneath that, the tools that you'll use and how you'll test it. So the next step is to design your project and validate your functionality. So that's going to be in our September 23rd Zoom meeting. I hope you can join us. If you can't, you can watch the recording after. And if you have any questions, of course, you can contact the library. You have their number. And there is more information on science projects on the neostem.org website. And we'll talk to you soon.